This show is brought to you by our generous sponsors. Thank you for all your support in the production of this Career in STEM series.
Hello everyone, welcome to Careers in STEM series. My name is Akul Gunukula and I'm a sophomore at Troy High School.
Hi everyone, my name is Tanisha Panchal and I'm a junior at Troy High School.
We are FRC Team 226, the Hammerheads from Troy, Michigan, consisting of over 100 high school students from Troy and Athens High School.
We've been competing in the first robotics competition since 1999. This Career in STEM series is a bi-monthly show occurring on the first and third Thursdays of every month. During these episodes, we interview an individual working in the STEM field and learn about their experiences.
Also a reminder to put your questions in the chat where we will answer them throughout the interview. Today our guest is Mihir Patel. Mihir graduated from the University of Michigan with a Bachelor's of Science in Computer Science and Aerospace Engineering and a Master's in Aeronautical Engineering. He currently works at the Aerospace Corporation as a technical staff. For this series, we'll have a 40-minute interview period and we'll be answering questions from the chat periodically throughout the interview.
Awesome. So Mihir, our first question for you is, what activities did you do in high school? This could either be your first robotics experience or any other clubs.
Yeah, so when I was in high school, I went to Troy High and graduated in 2015. And while I was there, I was part of the first robotics team, Team 226, where I was the engineering VP for 2 years and the build lead the year before that. And I was also part of the band, in the marching band. And so in the marching band, I was part of the drum line. So I played bass drum for 1 year and I played tenor drums for the other years.
So on the team, what were your responsibilities? What did you do?
So as build lead, my sophomore year, the focus was primarily on the robot design. And so during the build season, pretty much every single day we were there. And the focus was on, within the first 2 weeks, was to get the design started to the point where we could start going to the GM Tech Center, which is where we would build the robot. And so once we were probably sufficiently along, 70, 80%, that's when we would start going to the Tech Center and we would continue the design for a few more days while the rest of the members who were there would start on the manufacturing of like the chassis and other components that were already completed. And then as the engineering VP, it was a similar responsibility, but it also extended further out to training new members during the off season, working with the outreach team to make sure that the robot was available for various outreach events, making sure the robot was functional, making sure that everyone was trained up on how to set up the robot, these sorts of events in the case where myself or the other build leadership were unavailable. So it was similar responsibilities, but extending further to essentially all engineering aspects of the team.
Mm-hmm.
So in terms of the classes that you took in high school, what APs did you take and how do you think they helped you with your career field?
So I took a lot of APs while I was in Troy. I took calculus PC, took statistics, I took US history, chemistry. Those probably were the main ones. I might have missed one or two, but I think it was really good to get that sort of challenge earlier on in high school, and it allows you to really get a feel of what it's like or the speed of classes when you're in college. But it also is it's an advantage because if you can get those AP credits while you're in high school, it allows you to have like a lower course load while you're in college. So instead of taking 16 credits per semester, which is the equivalent of about 16 hours, which is the normal amount to finish within 4 years, you could take 12 credits or 13 credits. So it reduces the amount of, essentially reduces about one course per semester, which goes a long way when you think about how much time you're spending studying, doing your homework. Yeah.
So in terms of APs, I know you didn't mention physics, but obviously I assume that you did physics.
Yeah, I took physics 1. Actually, no, I did take physics C while I was there. I ended up getting 4s on those exams, so I had to retake physics while I was in college. But I think even though I didn't get the credit for it, it still gave a really good foundational background. And so when you're retaking the class, I would say physics is one of the harder courses in like your entry level engineering courses, and having the experience of going through those classes, at least getting a foundational set of knowledge, it really allows me to focus on certain aspects that I didn't grasp on so easily. And so it definitely was a huge advantage when I was actually taking that class in college.
So in high school, were you pretty dead set on doing some sort of engineering STEM related thing, or were you still wavering, or was it still some like experimenting that you wanted to do?
So at first it was a little bit of wavering. I was interested in the medical field for a little while, and initially my freshman and sophomore year, that was where I was geared. And then slowly shifted more towards maybe like biomedical engineering. I still want to do something in the medical field, but maybe not going to med school or being focused on that aspect. And then probably towards my last 2 years, I think when you start taking some of the tougher science classes, you really get an idea of the sorts of information you'll be learning, the type of retention that you need. And it was just something I did enjoy doing. And so kind of that was when I started pivoting more towards engineering. So mechanical engineering, aerospace engineering, and ultimately I ended up choosing aerospace engineering.
Was there anything specific that made you choose aerospace engineering? Because obviously there's a lot of diversity in the engineering field, and there's a lot of potential ways that you could go. Why aerospace specifically?
So this was something I was tackling or battling between during my freshman year of college, was choosing between mechanical engineering and aerospace engineering. And one thing that's nice at the University of Michigan is during your freshman year, you have 1 semester intro to engineering course where each the options that are available for that course are topic based. So if you're interested in electrical engineering, they have 1 semester course that focuses a little bit more on electrical engineering. There's a mechanical engineering one, and there was an aerospace engineering one. And so I ended up taking that one just to see what those sorts of classes were like, or what sorts of information that you learn. And one of the biggest takeaways that I got from that class is, as an aerospace engineer, you tend to have a lot more breadth in what you learn. And so you'll have a little bit of mechanical engineering, a little bit of electrical engineering, a little bit of computer science, a little bit of controls. And it gives you a much broader understanding of the field. And you may not necessarily go as deep in all of those areas, but if you're interested in things like systems engineering, doing design work, doing conceptual design, something I was really interested in, both from robotics as well as throughout college, and the different activities I did in college, was conceptual design. Trying to choose, given a problem, the best approach, or how do you approach solving that problem. And by having that sort of breadth, I thought it was really something that I wanted to do, or it would really put me in a position to be able to get a job in a role where I could do that sort of design work or systems engineering work.
So talk a little bit more about why you chose specifically aeronautical engineering, aerospace engineering, and aerospace engineering, right? And also went back and got master's. So what does it do? How does it help? Why?
Yeah, so like I was saying, it's a very broad major. And so typically for your master's degree, you'll focus on one of those fields that I said. And so for myself, I focused on structures and materials. There's probably the largest group of students in the master's track will most likely do like gas dynamics or aerodynamics, focusing on that side of things. But then there's a group that will be really interested in structures, and probably the second largest group will be the controls group. And those are mostly the three fields. But it really gives you that sort of depth that you're expected to kind of learn if you're a mechanical engineer, for example. And a lot of the courses that you take in the aerospace master's track is very similar, or even overlaps with a lot of the mechanical engineering courses. And so a lot of the classes will be courses that master students in mechanical engineering will take as well. And so it really does give you that level of depth that you would need if you are interested in some of those mechanical engineering positions as well.
So while you were in college, what organizations were you part of? This could either be anything related to aerospace engineering, or you could even talk about any specific activity that you did related to aerospace engineering.
So while I was in my college, during my freshman year, I had joined the Michigan Mars rover team. And so that project team was an extracurricular team where they competed in a challenge each year to essentially design a rover. So similar to the robotics. And then as I started gearing more towards doing aerospace engineering, after my freshman year, me and a group of friends ended up starting our own project team. And this project team competed in AIAA, so the American Institute of Aeronautics and Astronautics. And we created RC aircrafts. And so every year there's a competition, probably in May, where each of the teams will create their own aircraft for that year's challenge and compete. And what was unique about that challenge compared to a lot of the other project teams at Michigan is that the challenge changes every year. And so the set of rules or the requirements of what the aircraft is due has to change every year. And so you start from scratch, essentially, when you're designing the plane. But in a lot of the other teams, it's the same competition every single year, and the focus is on refining your designs. Similar to what you see in when you're in the professional field, where you're not creating something new every single year, but you spend years and years trying to refine a design before you're in the production phase. Mm-hmm. And so that was one thing I really liked about that competition, was it really exposes you and gives you maybe the base level understanding. Is if you come into one of these other teams, a lot of the work has already been done and you're just in a very niche area trying to improve a very small aspect of it. But here you can see why a design was chosen and why each aspect was chosen the way it was. And so it really gives you a much broader understanding of aircraft design.
So how did oh, sorry. Go ahead.
And in addition to that, I was also part of the marching band. And so I was in the Michigan drum line, and we played at the football games.
Okay, so for the aviation building thing, how much did FRC knowledge and background really help there?
So I think it gives you it gives you an understanding of how to break down a problem. Like given like a set of rules, similar to FRC, there's just a PDF with a couple of pages, describing the rules, describing the constraints, and it gives you it's taught me how to essentially break down the problem to figure out what are the constraints that are geared towards the actual problem versus constraints that are just there to say, make sure you're just not too big, not too heavy, not just generally just like size constraints. And so it allows you to kind of address the problem and figure out where are the most important points you need to address. And then from there, there are a lot of I would say subtle things that may not translate one-to-one, but things like having a background in CAD, computer-aided design. When I was on 226, we had used Autodesk Inventor, but when we were on the design team, initially we had used SolidWorks, and then we switched to NX. And the interfaces for both those tools are, I would say, quite a bit different than Inventor, but having that background knowledge in terms of, for example, when you're creating a sketch, what are some of the basic stylistic rules you should follow when creating these sketches, or if you're trying to make a part. Having that sort of background knowledge really helped with quickly getting things done. And then kind of like one layer past that is time management. And because the competition changes from year to year, you have to come up with some sort of strict schedule and be able to execute on that schedule. And I think with robotics, it being only 6 weeks, it had a similar manner of being able to budget your time, figuring out and understanding how much time does each aspect is supposed to take, and knowing how to buffer your time in case certain sections take too long. So a lot of the things you learn as you're on the team for a couple of years, and the things you pick up going through the build process definitely does translate into these sorts of situations.
Yeah, so this is just a chat question. What GPA and or SAT, ACT score could it take to get into the University of Michigan's engineering program?
So I applied directly to the engineering program, and I had a 3.8 and a ACT of a 32. And if you look on the admissions website of the University of Michigan, they give bounds for a lot of the average scores for all these different things, and as well as the different sets of courses that people have taken and whatnot while they're applying. And I think another thing is a lot of these universities will have maybe not necessarily quotas, but they'll typically pick up the same number of students each year from the same schools. So being in the Troy School District is one of the largest number of students come from the Troy School Districts going to the University of Michigan, just behind Plymouth and Ann Arbor. So just being at Troy High also just gives you a huge advantage if you're able to be within those metrics.
Mm-hmm. Did you find that scores were more heavy, or that extracurriculars were more heavily weighed?
So I think, and this is something that definitely translates not just to applying to college, but as well as when you're looking for internships and full jobs, is that for scores, if you're not like the top of the top, there are a lot of people that are going to have the same, I would say, like paper stats or the same sort of resume. A lot of people have roughly the same GPA, roughly the same test scores. And the only way to really differentiate yourself is through those extracurriculars. And for them to be able to figure out, what sort of person, is this person outside of just the numbers? And what sort of personalities do they have? What sort of drive do they have? What are they interested in? Does it align with, what the university sees and or expects out of its students?
So while we're on the topic of internships, did you do any of them in either high school or college?
Yes. So I didn't do any in high school. In college, I had 3 internships. One after my sophomore year was at NASA in Kennedy Space Center in Florida. And then I had 2 in LA at the company I'm currently working for at the Aerospace Corporation. And so while I was at NASA, I worked on part-time as doing some software development, so about 10 to 15 hours of software development. And then the other, 25 to 30 hours, I actually worked in a ergonomics laboratory. So the project they were working on was, I was helping set up a motion capture lab to be able to analyze ergonomics while workers are putting together pieces of like the spacecraft, for example. And so they had software where you could essentially put on a VR headset and put it on a motion tracking suit, and you can immerse them in an environment based on like CAD drawings or 3D models, and have them try to put together or try to assemble mock pieces of hardware. And you can analyze the stresses that are in their back or the stresses that are in their various joints. And so it was a very different experience, but it was an interesting experience.
So moving on to FIRST related stuff, how have you connected? How have you stayed connected to FIRST after leaving FRC, graduating?
And so for a couple of years, during my undergrad, I actually would occasionally come back to 226 competitions. 226 hosts a FIRST Lego League competition, and so I had been a ref for a few years. I had judged a few years, so I definitely come back to like those sorts of events. And I always offer my help when needed. There was 1 year where there's some difficulty getting some mentor support at one of the days during the competition, so I offered to help with being the drive coach and just making sure everything was on track, at least on the robot side of things. And so I it's hard to be around when you're not within the city, but I try to at least keep in touch and help out when I am available.
So just going back to your NASA internship really quickly, obviously it's a really prestigious internship. What were some of the qualifications or the requirements for the program, or what's something that you think made you stand out specifically?
So I think one of the things is being able to, a lot of times when you're just working for the government in general, there's a high value in your GPA and your academics, but what specifically helped with my interview at NASA was I would say my passion or my willing to help out. And the group that I was working with was systems engineers, a lot of them aerospace engineers, but the work is very different than what most of them are doing. And so when you have when you're in that sort of situation where you're not really doing work geared towards kind of what the expectation is for those sorts of majors, it's really hard to find people who are interested, who will want to do it, right? And for me, it was I was there for the experience, right? Being able to say, I got my first job, it was at NASA. I was able to do something cool. When I first heard about what the position was during the interview, I thought it was like a really neat and really interesting thing. I'm into video games, I really like movies, and being able to just experience what it's like to do those sorts of things I just thought it was going to be a really cool experience. And so sort of showing that sort of passion that I was interested in what they were working on definitely gave me a leg up.
So
what were some of the skills that you needed for that internship? And did you get any of those from FRC, or did you have to do any external work for them?
So specifically for that one, a lot of it focused on being able to work with computers, navigate computers, diagnose network issues, hardware issues. And so a lot of that, some of it you can pick up just from, my home, my internet's still not working. Let me figure out why. If you're trying to set up some neat new, gadgets that you end up buying and connecting to your home internet. And so you'll figure out some of those things just from that. But the other side of it was, software development. And I guess I do want to correct you. In the beginning, you said I did a major in computer science. I actually did a minor in computer science.
Oh.
But being able to program, I had experience programming in Python and C++ at that point. That gives you a big leg up on most people who do aerospace engineering, and even mechanical engineering in general. And if you look in the aerospace field, I would say 50%, if not more, of the positions you will need to be able to code to somewhat. You may not be able to produce production code, but it might be, you have a big set of results in an Excel sheet. Can you post-process it into a set of graphs, or make a small script we can reuse every single time we run some analysis? And having at least that experience definitely gives you a leg up when talking to recruiters at career fairs, as well as during interviews, being able to say you have that sort of experience. And during my internships at the Aerospace Corporation and the work I do right now, I almost exclusively do some form of software development. So even though the focus is still on the aerospace field, especially in a lot of the tech and engineering companies, there is a large emphasis on being able to program. And so that definitely gives you a leg up.
So let's talk about your job right now. How did you go about coming to where you are right now in the Aerospace Corporation?
Yeah, so I actually did an internship for 2 summers while I was there. So one during my last year of undergrad, and then one in between undergrad and grad school. And so during my undergrad internship, it was once again, the interview was, because it was mostly a computer science job, there's some focus on programming. But at the Aerospace Corporation, there's a big emphasis on education. And so if you look at the distribution of degrees in the engineering group at the Aerospace Corporation, I would say about 25 to 30% of the employees have PhDs. About 45 to 50% of people have masters, and then the other, 15 to 20% are bachelor's or associates. And so there's a very large emphasis on the knowledge. And it's a federally funded research and development center. So their goal is to essentially advise the government. And so they have they really are just looking for experts in industry. And that was one of the things that really drew me to the company, was being essentially around the smartest people who have PhDs, or people who have passions or are experts on whatever they did their thesis on. And, they may not be working on whatever they did their thesis on while they're working full time, but being able to work with people that have that kind of motivation, that kind of drive, who have the ability to scope a problem, scoping a PhD thesis of, scoping the problem, doing the actual research and doing the analysis, and then defending the analysis. That was something that really, that was really interested in being part of, or being around essentially a room full of the smartest people in the world.
So the Aerospace Corporation, what exactly do they do, and what do you do on that company?
Yeah. So it's a federally funded research and development center. And so its primary customer is the government, although there are some other commercial customers. For example, recently there was a project with Lyft, so there are some other companies that work with it. But the goal of the company is to be able to advise the government and provide mission assurance and third-party analyses. And so if you have contractors, let's say you have a contractor like Lockheed Martin or Northrop Grumman or SpaceX, for example. If you have SpaceX who's saying, we're going to launch your satellite into space, they'll have us on the other side during the launch, verifying anything that SpaceX is saying is good on our end as well. So it's just like another layer of redundancy so that nothing goes wrong. And to make sure that the government is spending their money in the right way and they're not being, I don't want to say tricked by the contractors, but that they're, the focus is in the right direction and they're not wasting essentially taxpayer money. And so what I do, I would say it's two things. One would be software development, focusing on integration. So looking at being able to integrate analysis tools together into a more holistic sort of analysis environment. Then there's a focus on digital engineering. So in the Space Force, they have this, which was recently stood up. There's a big focus on reducing the paper trail and having all data be sourced from an authoritative database, for example. And so the goal of like these sorts of projects are to be able to understand how data should be structured in these databases, and then so that they can be easily used by whoever needs them. So whether it be analysts, whether it be systems engineers, being able to structure the data so it's usable by those people, and then taking it one step further to develop pipelines to be able to automatically transfer that information to those people. So one of the projects that I work on is doing that transformation, where it'll take data in one format, whether it comes from a database or some analysis tool, and it'll reformat it into a source file for another tool. So it reduces the amount of work that an analyst needs to do on their end to manually type in information. And then the last sets of projects I do are more of the analysis sorts of projects. And so I do a lot of agent-based simulations and discrete event simulations. But both of these focus on system of systems analyses. So not necessarily a single spacecraft, but a system of systems. So a bunch of spacecrafts working together to provide some capability. And so a lot of these analyses will focus on how do a bunch of these systems working together help support the user on the ground.
So you mentioned about how at the Aerospace Corporation there's an emphasis on education. You also said that your first summer internship at the Aerospace Corporation was in your senior year of undergrad last year, right?
Yeah, it was right before my senior year.
So did having that internship at that time influence your afterward plans to get a master's, or?
Yeah, so it actually did. And I would say during that summer, I was debating right before my senior year, between getting my PhD, going straight into, so it was mainly getting my PhD or going straight into the workforce. And then everyone in the department at the time had a PhD. And so I had a lot of people I could talk to see, what was your experience like? Why did you do it? These are the types of things I'm interested in. And ultimately, I decided that it wasn't something I wanted to do, that it wouldn't necessarily help me get where I want to go in the long term. But I really enjoyed what I did during that internship, and my managers liked me enough where they allowed me to work part-time while I was still in school during my senior year. Mm-hmm. So during my senior year, I did 10 hours a week, while I was taking classes. And when I went back for my next summer internship, they essentially had told me that before I actually went back for my next summer internship, they essentially told me that if I wanted to keep doing it, I would have to do my master's. So if I wanted to get a full-time job there, I would have to do my master's, because in my group specifically, typically they wouldn't hire bachelor's degrees. And so that was one of the reasons I decided to do a master's. But one of the things I was trading for a while was whether or not I want to do my PhD. And the reason I ultimately decided not to do it was because you spend a lot of time really getting into an area, and you have to be interested in that area. You can't just do a PhD for the sake of doing a PhD. You have to do it because you're really interested in a specific, specific topic in that field. And a lot of times you'll have trouble finding work related to that topic after you graduate. And so for a lot of the people I work with, their PhDs were in things like machine learning, optimization, but it wasn't necessarily what they were doing at work. And we do some of that stuff, but it wasn't the primary stuff that they do at work. And so it was that trade-off of, do I really want to become an expert in this and then maybe not use it again because there isn't value. And so that's what ultimately kind of drove me away from it. But I think it's definitely something people should consider, because one of the advantages of doing a PhD right after undergrad is that it also comes with a master's. Or if you decide you don't want to do anymore, you can get the master's within 2 years and then call it quits after that. And typically, especially in engineering, PhD programs are funded, so it's a way to be able to do a master's degree or get a PhD without having to pay for it as well.
So, how were you able to find these internships? And do you have any advice for high schoolers or college students on getting the internships?
Yeah, so during your freshman and sophomore years of college, it is very hard to find an internship. Like I was saying earlier, for when you're applying for high school, for college, there's a lot of people who have a similar GPA than you, and a lot of people who don't have any work experience. And one of the biggest things when applying for internships or when people are recruiting is, have you had internships in the past? So it's like a never-ending cycle of, have you had an internship? No, maybe come back next year after you've had an internship. But because there are so many people in that boat, typically the companies will want to hire juniors who have had an internship or juniors who haven't, but maybe will become full-time employees after. Because the point of the internship is to, at least on the company side, is to be able to hire those students full-time after their internship. And so for advice, I would suggest anyone who's serious about trying to get an internship like early on in college, they should always be going to career fairs, and they should always be applying online. At career fairs, you'll have to wait in lines and you'll have to talk to recruiters, and they may not necessarily be interested in you just because you're just a freshman, you're just starting off in your degree. But it really allows you to work on your elevator pitch, be able to talk about what you're interested in, what you're capable of. And that becomes important when you start getting to that end of your sophomore year, beginning of your junior year, where internships might come or interviews might come a little bit easier. So attending those sorts of events early on is important, so you can work on those speaking skills. And then it also gives you an opportunity to ask the recruiter, hey, what do you like about my resume? What are the things I could work on, so that if I came back next year, there's a higher chance that you guys could hire me. And they'll definitely give you good feedback in terms of what they're looking for when you say, like, hey, I want to do conceptual design. And they'll say, okay, if you want to do conceptual design, join a project team, show us that you can do some of these sorts of things, maybe learn some CAD, learn some programming. They'll give you those sort of advice. And you won't really get that advice unless you go to those sorts of events. And especially in the aerospace field, typically, if you're a government contractor, you have to post your most of your positions online. It's like so related to like equal opportunity. And so you need to be able to constantly applying, even if you don't hear back. Like maybe 1 in 50 or 1 in 100 application that you do, you might be able to hear back with an interview. And so it's just you just have to keep at it, and eventually it'll pan out.
So at the Aerospace Corporation, what does your typical workday look like?
Yeah, so right now I'm working on West Coast time. So I work from 10 to 7, about 9 hours a day. And at the Aerospace Corporation, they have a 980 schedule. So you work 9 hours a day each day, and then every other Friday you get off. So instead of doing 8 hours a day for 5 days, you do 9 9-hour days in one, or 8 9-hour days in 1 8-hour day. But for the most part, I work on anywhere between like 4 to like 8 projects at a given time. So usually I have 1 or 2 just project meetups in the morning, maybe a half an hour tag up where we'll just discuss, what updates from everyone. And we'll just do those sorts of around the rooms for each of the project teams. And then you'll usually have a couple hours where you can get the work that you need get done, but you also have a set of meetings that, for myself personally, where I work in like a more of an advisor role. So one of the things that I do is support a group that is developing a ontology for use in one of these digital engineering systems. And what ontology is essentially it is a kind of like a web or a hierarchy of of concepts. And so you start from the most abstract concept that you can think of, and you would slowly break it down into more detailed you slowly break it down to more specific sorts of concepts. And the idea behind doing this is once you have been outlined all the potential concepts you could maybe potentially be modeling in these pipelines, you can start saying that, a satellite in one tool and a spacecraft in another tool are all spaceships. And so if there's a spaceship in my ontology, you can say that the satellite in tool A goes to a spaceship in my ontology, and the spaceship in my ontology goes to my spacecraft or whatever in tool B. And so that's how you kind of do some of these mappings. So I'll be in meetings like that where I'll be providing those sorts of advisory things. So as the contractors are working with the government to say, this is what we worked on, I'll post some questions saying, could this be an issue, or I'll evaluate some of the work that they're doing. And then we also I specifically work on a lot of documents. And so if I'm doing a proof of concept work, or if I'm working on some of the digital engineering work, we'll be publishing style guides. So trying to explain, if we want to work on these sorts of pipelines, you have to adhere to a certain standard of modeling restrictions. So you have to model in certain ways to be able to more easily be able to translate between these different tools. And then obviously some documents that if I'm doing proof of concepts for certain types of analyses, once the work is done, I'll have to write up a formal document which will outline the process that was taken, some of the results, and typically most of these documents are published internally, but there are some documents that we sent out to the customers, some that we publish externally. So there are a lot of document writing and a lot of meetings, not necessarily long meetings, but a lot of meetings to do updates and do some advice. So I would say probably 2 to 3 hours a day. 2 hours probably on average is meetings, maybe 1 to 2 hours on document writing, and the other 4 to 5 hours I'm doing either analysis work, software development, whatnot.
So at the Aerospace Corporation, this is a question from the chat. What programming languages do you use mostly?
So for some front-end work, I don't have a lot of JavaScript experience, so most of it is kind of just poking around the code and making, seeing things I can recognize and making modifications to facilitate, some front-end changes that I'm doing, because I do most of the back-end work. Mm-hmm. For a lot of the back-end work, it'll be in Python, and most of the, I'll say simple programs where you may use post-processing data, or maybe not necessarily like reusable programs, will be written in Python. And then a lot of the more higher fidelity simulation modeling or simulation or tool integration, a lot of that will be written in C++. So I would say right now, maybe 2/3 of the program I do is in Python, and with 1/3 of it being in C++.
So this is another question from the chat, mixing two together. How was the transition from the Troy Colts marching band to the the U of M marching band?
It was actually very interesting. So the way the Michigan marching band works, the Michigan drumline works, is they don't do cuts, but the way the marching band works is they take more than the number of spots of people that perform, and they have weekly. Once you make past the initial audition round, then during the actual marching band season, they have weekly auditions for who plays during the games, and then the rest of the students will be in the stands and with the marching band in the stands though. But for the drumline, they have a similar approach, but they don't do any cuts, and the drumline, the performers don't change. So once you get to like the band camp, they'll set the line, and then everyone who's on the performance block will be performing at every game, and everyone who's not will not be performing every game. But you're still part of the drumline in the band, so you still have to be there all the rehearsals. You have to be there all the games when you're supposed to be there. And so I think the practice methodology and the level of difficulty for the pieces at Troy High are, I'll say the practice and the performance pieces are right where they need to be at the beginning of the audition process for the drumline. And so if you are keep up with those, practicing, if you keep up with the practice, like the exercises, and you do it religiously, for 30 minutes a day, or you do it, an hour every other day, that will be more than enough to give you the technique to be able to play. And I think being able to play the pieces that they play for a lot of their like drumline specific performance pieces is more than enough to be able to play a lot of the audition pieces that we'll have. And so for me personally, it was the audition process starts in essentially January and lasts the entire semester. And then you have camps once a month in the summer. And then you have band camp at the end of the summer, which is where they set the drum line. And I knew about 4 weeks in that I was going to get the performance spot for my for the bass drum, which is what I was auditioning for. So it ended up working out pretty good for me. And I thought I was pretty well prepared. And one caveat as well was I didn't audition for the marching band or drum line in high school. I actually decided not to do it for my freshman year. And I ended up making some friends who convinced me to do it my sophomore year. So I ended up auditioning after essentially not playing for over a year, or not seriously playing for a year.
So another question from the chat is, what colleges do you recommend for aeronautics in specific?
So for aeronautics, like the top universities are, MIT, Michigan, Georgia Tech, and then even like Purdue. And so if you want to stay in the area, like, Michigan is a really good school and Purdue is a really good school. If you're interested a little bit more on the research side of things, depending on what you want to do, I think Michigan and Georgia Tech are really good research schools. And Georgia Tech, a lot of the people that I work with have gotten their PhDs from Georgia Tech. And obviously, MIT is MIT, and so it's one of the top schools as well. But those four you should definitely drive for.
Okay. Some more questions coming in from the chat. The next one is, what region of the U.S. is better for aerospace-related jobs?
So for aerospace-related jobs, usually if you're on the space side of things, it's usually on one of the coasts. So, if you're in California on the West Coast, Florida, Virginia, if you're on the East Coast, obviously a lot of the manufacturing testing for a lot of aircraft. So if you're doing like military aircraft, a lot of that stuff is done in the South. So Texas, Nevada, Alabama. So I would say on like the outskirts of the U.S., not in like the central or like northern part of the U.S.
So another one, what are you most excited for in the future of aerospace engineering or general space?
So like I was saying earlier, the Aerospace Corporation does a lot of supports a lot of launches. And I think in these like near term to midterm, that's something I'm really interested in. And, for a while, it's, if you work at NASA, when they were doing the shuttle launches, that's the one position you can get. And other than that, there's not a lot going on. And now that SpaceX is about, if you work at SpaceX, you can have a similar sort of position. But this is like the only other company, one of the only other companies at the moment where you can get into those sorts of roles where you're supporting launches, you're doing, being one of those people like on the computer that you see in the movies that are, there when the rocket lifts off. And so I think, at least in like the short term or the midterm, that'd be a really cool position to be able to support. And there are some people in my department or tangentially to my department who do those sorts of roles. And so I think I'm in a place where I could navigate into that direction. But the other thing is, I had said that I was really interested in conceptual design initially. And the reason why, I guess what I had realized is the reason I'm into it is I enjoy doing the problem solving of figuring out how to approach a problem, how to solve it. But I'm not necessarily a huge person who is who really likes getting into the details on like a day-to-day basis, the same sorts of details. And so, I really like doing design, but if I had to, just CAD all day, every single day, it's not something I'd be interested in.
Yeah.
And I think being an advisor to the government, you're not doing a lot of that, that sort of work. You're doing a lot of more project management or systems analysis sort of works. And so you're working on a more of a conceptual, at least within my department and most of the projects I've been exposed to, a lot more on the systems engineering or conceptual design, or on a little bit more of on a macro scale, as opposed to just like a single satellite or a single spacecraft or a single plane. So I'm looking forward to being able to get into more positions like that, where I can help influence decision making and be able to work on entire programs as opposed to just a single system.
So you said that you were involved in launches, right? How were you involved in the recent SpaceX Dragon launch that docked at the ISS?
So I'm not involved in any launches. That's kind of where I want to go. I do have some coworkers who help support those sorts of launches, though, and so they were doing some of like the collision analysis or verification to make sure that there are no collisions during one of those trajectories. And so, I think I do want to get into one of those positions as over the next few years.
Yeah, we have another chat question. Where do you have to live to work on a military aircraft?
To work on a military aircraft, so if you want to work on like designing like military aircrafts or like manufacturing them, a lot of that work is done like in the South, so Texas, so some of it in New Mexico, Nevada. I would say like in those areas, I know a lot of that work is being done. Typically on the coast, it's more, at least in like California and LA or on the West Coast, it's more related to acquisitions and more on the space side. So, purchasing and more focused on the space because a lot of the launches are done over there. Mm-hmm. But if you're interested in doing like aircraft work, a lot of that is done more in like South Texas, Nevada, New Mexico, around those areas.
So do you have any sort of specific advice that you haven't already mentioned for high school robotics students or in general for participating in the robotics team or future?
Yeah, so I think you should, one of the biggest takeaways that I got from robotics was being able to learn how to manage my time. And robotics can be a very large time sink. Mm-hmm. And you'll always run across those situations, especially in college, you'll run across those situations where either have an assignment that's taking a really long time or an exam coming up, and there is a balancing act. And you have to be able to learn how to manage your time, both getting your work done, but also related to your mental health, right? Being able to take sufficient breaks, making sure you're not up super late, being able to, maintain good mental health while you're in college. And I think learning those skills while you're, in high school, when you can do robotics or things like marching band, that take up large amounts of time, and learning, what's the best way for me to manage my time? What's the best way to me to manage my sleep cycles? What's the best way for me to deal with stress? I think being able to figure those things out early on really will have a big impact when you first start college.
Yeah, and we're nearing the end of our time here, but I think we have time for one more question. So is there any other information that you would like to share with us, any advice that we haven't covered already?
Yeah, so I'll give this one tip. I think when you end up going to college and you're starting your freshman year, I would not, you try your best to have an idea of what you might want to do. But your focus, your freshman year, even to a certain extent, your sophomore year, should be to figure out what you don't want to do, right? Mm-hmm. So try to expose yourself to as many different things as possible, even if you might not necessarily like it, because as you start getting more and more geared towards one area, it can be difficult to switch. The further along you are, and so figuring out what you don't like to do, and then as a first thing is definitely something that you should try to do. That would be my my 2 cents. Be able to do as much as you can so you can figure out what you don't like to do.
Nice. Thank you so much for joining us today. We appreciate all that you've done. And thank you all for joining us today as well. Remember to subscribe to our YouTube channel.
And make sure to come back in 2 weeks on May 20th for our next show. That's it, guys. Have a good week, everyone.